You can hear me on high heels. And now it's male. And now it's female. Let me show you what else this component can do and how you can use it in your projects, besides just appearance reasons. So we can go here, we can go into AGR Sound Master. We already went through some of the setup. And if I right click on this component, I can add an event. And I have an event, add character made footstep sound. And this is a bit confusing because it's not just sound, it should be actually character made footstep. Because if I add it to my character, now I have an event which triggers every time that actual footstep happens. So I can do a print text, and I can do a format text, and I can provide you with a lot of information about the footstep itself. So I can say surface 0, then I can say volume 1 and location 2. Okay, so those three informations, I can go from here, get surface type, and I can say no, not to text, but enum to name or to string, doesn't really matter. Let's say to name. This is a wildcard compatible one. Then the second one is volume. I can send it directly, and location. I can rake hit point, and I can say impact point. Vector to text and specify it here as well. Okay, so now on each footsteps I will be printing out those information. I'll be printing them out for, let's say, 10 seconds. So let's compile, save, and let's hit play. And I already got two informations. Okay, let's now do something else. I will, this is, the third one is irrelevant actually for us, so we'll just cut it down. Those two are relevant, and I will show you why. Because right now we get this volume multiplier, which is being calculated based on our velocity, and those are the velocity threshold of min and max speed. So what we want to do is we want to be able to slow down our character. So this will be working only on single player, because the component itself works on multiplayer, and I will show you how to use it on multiplayer, but this is just a very quick and dirty way to show you how it can work. So let's say left control, and when I press it, I will get movement component. I will set max speed, max walk speed, and I will cycle between 200 and 360. And I'll just go into this or this, cycle speed, and just to show you how it works. So if I hit play now, and I am moving fast, if I hit control, I am moving slowly, and now my volume value drops to 0.467. And now it goes up to 1. Okay, so what we can do with this volume, let's delete that and let's go back here. So what we can do with those all values is that whenever we make a sound, we can, for example, use a function pound make noise, which is an AI function, and this is being triggered on the server. And to understand how this works, the entire component is not replicated, which means that it is running separate instance on the server and separate instance on the client. Any way to tamper with it on a client, so any cheat tries, will end up in tampering only locally. So locally, you can, for example, make footsteps louder, or you can know their location. But if you are cheating, you probably already are using wall hacks or something like that. So that doesn't really improve your performances in any way. But you cannot force server to use your setup. So server is running its own instance of SoundMaster and its own event being run as this notifier. So on the server, we can make this character make noise and notify all other AI agents in a certain distance about what's happening. So we can, for example, break hit, say that our impact point is the noise location, the loudness is this volume multiplier, the target is self, use noisemaker location, this way it's set to true, and noise maker, which is an actor object reference, is the actor that actually made this sound. So pound make sound means that, for example, we can throw a brick into water, and when it hits the water it can make sound, and we would also use pound make sound. We wouldn't use different function, but we can specify that the noise maker was a separate actor. It wasn't us per se. So any AI that receives this message on his AI senses will know the location and what happened about the brick itself, not the actor that threw the brick, that can be, for example, hiding in the bushes. But for our particular instance where the character is making sounds, we are just referring to self, so this actor itself. And compile, and now our character, when it's walking, is actually making sounds that can be heard based on certain distance and this loudness by any AI. And this is being calculated automatically, so this value can go between 0, 2 and 1. It can't go below 0, 2 right now, but if we want to, we can go here and we can create a blueprint class, and we can specify that our blueprint class is AGR Sound Master, the C++ base class from the plugin. We can call it BP Sound Master Custom. And this Sound Master Custom right now is exactly the same component that we are using here. It's not different in any way, but we got some functions we can override. And we can, for example, override calculate volume. And this one is just returning calculation volume from the previous one, but we can, for example, specify that we want to map range clamped, and in value between 0.2 to 1. We want to output in between 0 and 1. And now we can rescale those values into those values, or for example, we can then multiply it by some other value, and this could be a variable called move silently skill check. And let's say that by default it's always 1, but we could make this something different, or it can actually be a call to an other component or some other variable source, like ability system variables. And we can make those custom calculations, and those calculations on this return value will be used here. For other override functions, we go into override particle scale, and right now the particle is being scaled with the parent. So if our actor is scaled 1.0, then the particles are scaled 1.0 as well. But if we make our actor bigger, his footsteps particle will also get bigger. That's quite obvious. But you can also set it up to be something absolutely custom. And the last override is the overwrite pick surface. And this one has an input of surface from the trace. And then you can do some other stuff to the surface. So how you would use it is, for example, you can have a branch here. And you can have a condition that you promote to a variable. And this condition will be called in water. So if you are physically standing in water, so this would be turned true if you go through water surface trigger volume, which means that whatever surface your footsteps are now touching underwater, they will act as water. So if you are not in water, you will just take the surface from the default one. But if you are in water, then return node will always return water. This way, by making your custom SoundMaster component, you can have absolutely full control over any aspect of how it works when interacting with AI, when interacting with physical volumes, physical surfaces, and changing circumstances. You can also, at runtime, change your data asset for the footstep component itself. So this variable is just editable from anywhere. It's public. But remember that if you make any changes locally, if you don't make the same changes on the server, it will not affect the server, and the server is the only one that can interact with AI. So this goes for the in-depth what this component can do and how it can be used for a lot more than just things that are visual and purely cosmetic, and it can affect your gameplay mechanics as well. So thank you for listening, and let me show you some more details and more examples in the next episode. Bye. Hi and welcome back. We'll be talking a bit more about the sound component from the AGR family. And in this episode, we'll be going through one of the packs I already mentioned, which is called the Footstep Sounds with Blueprint. So what if you added a pack to your project that is already set up, but you don't like the setup? Like right now, if you go into Footstep Sounds and you go into the character and where is it? Footstep Sound Blueprints. Okay, so if you go here, this is like a lot. And if you go into the anim graph, it also does a lot that I don't really think is useful in any way. So if you want to drop it, but if you want to use these footsteps as designed, and I must say that the sound design is absolutely perfect, and everything that you have here in those three are absolutely perfect as well. So if you want to use this, specifically this, without any alterations, you can, and it's super easy, and I'm going to show you how. You just make a new miscellaneous data asset, and we'll call it DA underscore footsteps, let's say advanced. Okay. Oh, classes will be DA underscore footstep config select, and this one will be called DA underscore thank you, footsteps advanced. Okay, and for footsteps advanced, for particles and sounds, for particles we'll say default nothing, attenuation will be same as previously. Minimum velocity will go from 120 to 360 as before, nothing changes. And sound default will go into this footstep queue. So what happens is that if you walk on a surface, any of those surfaces, and inside your configuration file you don't have surface specified for it, it will just read the default. So right now we are always reading this footstep sound and no particle whatsoever. Okay, so let's go back to our footstep character, and not this one, to our mockup character, and here we'll delete this example, it's no longer important for us, but we want to leave this character made footstep sound event, compile, save, and if we go, okay, I can close all of those, and I don't really have to do anything else here, so I can close this as well, and I can go, oh, you know what, we're going to do one more thing. We're going to open both our configs, and from this config I will just copy the entire map of particles and paste it here. Okay, save it, and here we have only one sound. So right now if I hit play, I will actually not hear anything, and I'm going to explain why. Print string, and on print string we're just getting display name of this sound. So if this sound is being played at all, or we can actually even get let's see, audio components, audio component, get okay, just get the display name just to show you that it exists but it's silent. So if we hit play, oh, we haven't changed one in our mockup character, so we go here and we just change our footstep setup to our footsteps advanced, compile, save, play, and it doesn't do anything, but there are audio components being spawned. And don't worry about the numeration, because the previous audio components are auto destruct, so they are getting destroyed on the way as well. So okay, but we cannot hear anything. We can't hear anything because if we open it and we'll just run it as is, we also can't hear anything, because there's a lot of parameters here that we need to set up in order to make it even being able to hear it. So let's go from the start, and we have this mixer, which is okay, it just mixes those two, and we have branches that uses parameters. So we have step play and rattle play. Let's use those. So we go into queue, set bool parameter, it's step play, and the second one is rattle play, and both are true. And this is the same queue, we don't need this. So now we just say play steps, play rattle, true. We go back here, and let's go further. We have continuous modulator. This also uses a parameter both here and here. So you have step volume, set parameter, float parameter, step volume, let's say 1 always. And let's go here, and we have rattle volume, and let's say always 1 as well. And I think we got some more. So this is this, switch floor, and then we have here random mix and is male bool parameter as well. So bool parameter is male true, and we're going to play with those parameters in a second. So 1, 2, 3, 4, 5, and we got one more that is here, which is switch floor. So we have floor int parameter. Okay, okay, can we do select? We can do select, that's cool. Okay, so from hit event we need surface type, and we specified it here, and we got a surface type. And we know that default is 2, carpet is 1, concrete is 2, grass is 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's make sure it's like this. 0 is skipped, and this is unset default, and 1 is the first one. Okay. So now we're taking surface and we are pushing it as a parameter to our queue. So let's test it now. We set 1, 2, 3, 4, 5, 6 parameters. Save, play. Okay, it works. And now if we want, for example, to inside just gameplay mechanics without even touching this, we want to, for example, say that rattle volume is a bit too loud. Let's say 0.3 is enough. Play. Okay, now rattle is a lot more subtle, but if you want to have the step volume also a bit more silent when we are so it's a lot more silent when we are not moving, a lot more subtle. And we can also say that this is multiply by, let's say, 0.5 times our volume. So it will also be a lot more silent. Okay. And this way I haven't done any changes to the pack itself, and I am using directly what is already predefined. And when it comes down to like sound cue design, this is working absolutely perfect. And we can do some more stuff. So for example, if we say left control, and we'll make a new variable, we'll call it male. We'll also set, and we'll do flip-flop, and let's do default no. Okay, and now if we run it, we'll have different sound if I hit control. Oh, we don't have different sound because I forgot to plug it in. So I'm changing this isMale variable, but now I have to just plug it in here. Okay. Compile, save, play. You can hear me on high heels. And now it's male. And now it's female. And we can also say that, for example, female might not be rattling at all. So we can also say rattle play is also male. So now male will rattle and female will not. And you can do a lot of stuff with different variables when it comes down to just setting them directly from this event. And you can do the same with particles. So for example, you can set scale. Or what can you do really cool with particle? I'm not very good with Niagara, but you can, receive particle. Okay, you can attach to this particle data directly. That's cool. Okay, so you can just use this sound and particle directly to set parameters and to do stuff with them from the game itself. So yeah, there's that, and we have one last topic to go through for this component, and we'll be all set and done.